try to jolt you all awake a little bit, and try not to take too much time. So on the 9th of January this year, the Freedom Industries in Charleston, West Virginia spilled 4-methyl-cyclohexene methanol, which is an alcohol, into the Elk River. And the Elk River leads out into the Kanawha River. This chemical that was spilled is broken down into a naphthenic acid, which has acute and chronic toxicity in fish. And the Kanawha River, before it runs out into the Ohio, has a dam in the Winfield Dam, which is also a major hotspot for catfish fishing. And so my question throughout this is basically, how would the dam and the pollutants interact, and what is the effect on fish? The name of my talk is More Than the Sum of Its Parts, and this is kind of an ideas talk. So I want to discuss the combined effects of dams and anthropogenic pollution on fish. It will be kind of a wide talk, any type of dams, any usage, any design, any type of anthropogenic pollutants. Could be heavy metals, persistent organic pollutants, pesticides. Kind of discuss what could be the effects of the combined effect, not just one or the other. Why is this important? There's a lot of research on what dams do to fish. There's a lot of research on what pollutants do to fish. But there's not, and there's enough of that research that I think it's time that you could look towards how do they interact, what do dams do to pollutants to change them, and in lesser amount, what do pollutants do to dams to change their effect on fish. And this is especially important because dam rivers are often polluted rivers are often dammed. In fact, dams are often polluted because, rivers are often polluted because they're dammed, and vice versa. So down here is this is an aluminum smelter on the Columbia River, and it takes 25% of the power from this hydro dam. So if that hydro dam hadn't been there, that river probably wouldn't have an aluminum smelter on it. And, well, aluminum smelters give off a lot of pollution. And the same way, you often build dams to irrigate agriculture, which leads to pesticide and fertilizer runoff. And rivers where this is often, some rivers, I mean they're everywhere, but some rivers is the Ebro River in Spain, which this was actually, the picture is from the Flix Dam, that's chloride industry behind the Flix Dam on the Ebro River in Spain. There's the Dona in Central and Eastern Europe. There's the Wenyu River in China, the Columbia River, and the Hudson River here in New York, where both dams and pollutants interact. So the first kind of effect that I want to talk about is the temperature effects. Dams change the temperatures of rivers, both absolute and in variation. And it basically depends on, it changes it because velocity changes, because surface area changes. But especially with dams, depending on if the intake is in the warmer upper layer of the dam reservoir or in the lower colder layer. So if the water is let out from the warmer upper layer, that means warmer water downstream than what you would expect otherwise. And we know that increased temperature in many fish species lead to increased respiration by the fish. And increased respiration leads to increased uptake and metabolism of pollutants. So this is a little bit hard to see, but you have oxygen consumption, methyl mercury uptake, and up here is all of the, it's 20 degrees. So if it's 20 degrees Celsius, you have higher oxygen consumption, you have higher methyl mercury uptake, while compared to 10 degrees, you have lower uptake, lower oxygen consumption. So if you have fish that are basically out below a dam, with which takes water from the upper layer of a reservoir, then they're going to take up a lot more methyl mercury than otherwise, and other pollutants as well. Related to this is oxygen effects. In the hypolimnial, the bottom layer of a dam reservoir, dissolved oxygen is often low. So if you let out water from that layer, you will have lower dissolved oxygen below the dam. If this is combined with high biochemical and chemical oxygen demand pollutants, like fertilizers, it might cause serious hypoxia below the dam or in the bottom layer of dam reservoirs, which works together to affect fish. There's concentration effects, where dams can basically lower the amount of water downstream, either through evaporation, because you have a larger surface area of the water reservoir, because you're diverting water for agriculture, for industry, or it could be seasonal storage. For you're waiting for high power demand, or you're storing it up for some reason. And these kind of concentration effects can, especially with seasonal storage, so these kind of concentration effects leads to, even if you have a set amount of pollutants, if you have a less amount of water to dilute it with, then the effects are going to be stronger on fish downriver, just because the pollution is more concentrated. And with kind of seasonal storage, there's a risk of an effect where it lines up with higher release of pollutant and with migration of fish. So a lot of my background is in India, and there's a crucial food fish called the hilsa, and they have a spring migration. There's also a spring harvest in India, which means a lot of fertilizer runoff, a lot of pesticide runoff in the spring. And spring is also a time when hydro plants generally store up water because there's a high power demand in the summer with all the ACs and all the cooling in hot parts of India. Somewhat related to this is the apparent effect that fish will be, if there's a dam, fish will be cut off from less polluted tributaries. Generally, pollution is more severe further down the river, just because there's more industry, more agriculture in the lowlands. This is trying to illustrate it here. There's a river coming down. This is the Netravati River in south of India. You can kind of see how green it is, nice up in the higher tributaries in the mountains, and then more and more agriculture, more and more development the further down you get. So if the dams stop fish from coming up, they're stuck in the most polluted parts of the river. Related to this is increasing the fish's time in polluted areas. Often dam reservoirs often concentrate pollutants, depending on how they move in the water, depending on their density, transportation method. Pollutants often concentrate in reservoir water or in sediment, and reservoirs are often stocked with fish to offset loss of fish in the river. And especially in developing countries, the fish can be a crucial protein source. So what you get is fish that are trapped in a very polluted environment in this reservoir. Furthermore, fish that is damaged by pollutants, either physically or neurologically, they probably have less success navigating fishways and out of reservoirs. So they will be even more stuck. It will be kind of a negative spiral, so to speak. You get fish that can't work their way up the fishway, and then they will be stuck below it with even more taking up even more pollutants. So what fish are most at risk? This is my question, part of my question to the room. I think we need to look at benthic feeders and reservoirs because a lot of pollutants get stuck in the sediment. We have fish that migrate, like the hilsa, migrate at possibly at low flow from dams and high flow of pollutants. Fish that get stuck below dams with either high temperature or low oxygen. We also have certain life stages, like we know that embryos are more easily damaged by pollutants. So if eggs are laid in the dam reservoir, for example. And I was hoping to get some input on how you think these effects can be evaluated. How can we separate the dam plus pollution factors from just the dam, just the pollutants or other factors? And how would this impact management of fish? Should we have should we manage by having more water to dilute when there's high levels of pollution? Should we try to not stock fish in reservoirs but in other places? Should we blow up dams? That's it. Thank you very much.
There's time for questions and discussion.